Hello dear students, myself Prakash Ranjan, your physics mentor. Today I am going to discuss again some from Pathfinder physics for Olympiads from electrostatics topic. So I am going to share the question, might be you have seen this question earlier also, but today I will solve this question through superposition method. But I request to my students who is attending my class to attend this question through pressure method. So that method will be quite easy. So let's see. Two hemispherical thin cells made of insulating materials are concentrically arranged in a free space as shown. The radii of a larger and the smaller hemispheres are capital R and small r, and they carry net positive charges capital Q and small q respectively. The charges are uniformly distributed over the surface of the cells. Find the force of electrostatic interaction between the cells. The similar kind of question we have seen in the gravitation also. So I am going to use the same concept. So what we can think about this sum, because if you look at this sum, then directly you cannot apply Coulombian formula because this is not a complete sphere. So how we need to think is we can assume suppose there is a complete sphere in which if you keep any charged conductor inside this is placed concentrically only, then we can say net force would be 0. What does it mean? Whatever be the force, one can say this portion is applying on this hemisphere, the same equal and opposite force will be applied by the opposite portion of this complete sphere. What does it mean? If we assume that this portion, right portion of this complete sphere is applying the force on this charged hemisphere in the leftward direction, then this remaining half of the portion will apply on this hemisphere in this direction only, F, such that net force on this hemisphere inside this complete charged hemisphere will be 0. Similarly, one can say if we take again a complete hollow hemisphere, charged hemisphere, and again if we place concentrically the another hemisphere now like this, then what we can say is the force on this hemisphere due to this portion will be again in this direction, and due to this portion will be again in this direction, and again this will be net force 0. So this FF is going to be cancelled out. So if we flip it like this or like this remains the same, and now we have to take advantage of this information. Now we can think this is complete hemisphere inside which there is one more complete hemisphere. Then we can say if we superimpose these two informations, then what we can say, this F on this hemisphere is due to this portion in this direction, and on this portion due to this will be again F, because if you combine these two then it will form like this, concentrate on this inner sphere. So we can say this F and this F becomes 2F on this rightward direction. Similarly, on this remaining half we can write this will be 2F, such that again net force would be 0. So from Newton's third law we can say definitely this sphere is also applying some force in this direction with 2F, and in this direction on the outer sphere 2F, so that all are in equilibrium. So we have to take advantage of this information here, and what we can say, if we take the outer hemisphere like this, on which definitely only a force is acting, but we have to take the advantage of this information. If inside there is a complete this sphere, then due to which force was acting as 2F and 2F. So we need to calculate this 2F value by assuming this as a complete sphere, and what we can say, here charge was given as a Q, then we have to assume that here QQ, which make it the total charge on this inner sphere is 2Q, we can say. So due to this, if we need to find the force on any small portion of this sphere, then I think I have taught you the projection of area, if you remember. So the force on this we can write as a dF, and dF is nothing but we write dq times electric field, we can say. And here this electric field is due to this inner hemisphere, that we can write 2q by 4 pi epsilon naught r square, right? So if we assume this angle is suppose theta from this vertical, and further we can write this dq is nothing but sigma dA times E. So we can take the component of this force. So one can say the net force will be in this direction only. So this angle is theta. So this is definitely dF sine theta. So we can say the dF sine theta value is nothing but sigma dA sine theta times electric field E. So to get the value of this 2F, we need to integrate it. So we can take sigma and the value of E, which we have 2q by 4 pi epsilon naught r square as a outside, and this dA sine theta, if you remember, is nothing but its projected area on the base. So after integrating, we will get this projected area, if you remember. So this will be directly, we can write this is nothing but pi r square, isn't it? So here the value of sigma is nothing but charge on this outer sphere, that we can write capital Q by its area is 2 pi r square. So if we substitute this value, then Q by 2 pi r square into 2q by 4 pi epsilon naught r square times this projected area pi r square. So this pi r square get cancelled out, isn't it? And this 2 and 2 is cancelled out. So we are getting QQ by 4 pi epsilon naught rs. But remember, this is the value of 2F, because we have make it this complete sphere and we are applying the Newton's third law. Whatever the force this is going to apply on this half portion as a 2F, this will also apply the same force from 2F on this complete hemisphere. So we need to take the advantage of this information. So now we have 2F value is equals to this. So F value would be QQ by 8 pi epsilon naught r square. This is the required result. This is answer. So you can solve this question by own also by applying this concept. So this is all for the day. Thank you everyone. Thank you for watching my channel.